like we would like to begin by introducing the scientific method and just talking about exactly what it is, because we know that in the past people didn't always know or have an idea of what the scientific method was. They just saw, for example, that it was raining, and then they made an association between the clouds and the rain, and they thought, oh, there must be something going on here. Or sometimes they also made associations between, I went to this place and there was an old lady that looked at me badly, maybe that's why I'm getting sick. So sometimes the associations were really what we would say irrational. And so over time, they began to look for different ways to be able to test for these systems to get the scientific method that we now know and associate with that. And that would be truly, it's not pseudoscience, just things that they are thinking. It's not anecdotal observations. It's just a way that they have figured out to explain exactly why this is happening the way that it is. We begin our discussion by talking about Plato. And Plato was one who thought that we could reason our way through anything, that if you knew why a phenomenon will happen, you can think about it, reason through it, and arrive at the logical or correct conclusion without ever having to conduct an experiment. And a lot of people in that time thought that way, a lot of philosophers. And there's a lot of things that we truly can arrive at the correct conclusion without just by reasoning, but it's not everything. So later, several centuries later, we have Aristotle. And Aristotle was the first one to realize that it's important to make measurements in about everything. And he was very well, diverse. He had poetry talent, and he had a bit of science and a little bit of everything. And one thing that we find that he said was that you could find the nature find out more about nature by studying different species, and he studied about 500 different ones of them, and he arranged them in different categories and like that, and he was able to distinguish these are things that come in numbers, these are things that are qualitative, and we need to make those distinctions, make classifications, observe them, and talk about them. So he was one of the first who was starting to give us that if you make systematic observations, then you can make conclusions from them. Another thing that I find really interesting is that the Greeks were not actually the first people to actually have the knowledge and the information. Way before we had the Greeks, we actually had the Indians and the Egyptians, and they were doing math and calculations and figuring out a lot of physical things. So it wasn't just that with the Greeks or the Romans, the formal education that we know now. Way before that, these people were already, the Indians already were doing high-tech math. And so after the Greeks and the Romans, before the Greeks and the Romans, but parallel to Plato, the Greeks of Plato's time, then we had the Muslim, I think it's called the Golden Islamic Era or something like that. Some history major should correct me where I'm wrong. But during that time, they were now beginning, the Islamic people were way ahead, and they were beginning to realize that they needed peer review, because a lot of the patients were dying. So it was like, when you treat a patient, can you write down the things that you did, so that should they get better or should they die, we can look back and be able to figure out, oh, this is the way that this is done. So that whole idea of documenting things, and also the idea of being accountable to someone, being told this is nonsense or this actually makes sense, that was also there at that time. The other Muslim guy that is really famous was Al-Haytham, and Al-Haytham is famous for coming up with realizing that because we are human, we're not perfect, and sometimes we'll take readings inaccurately, so there's human error to the readings, or when we're doing a surgery, you'll cut too much or cut too little, and there's human error contributing to this. So he brought in that whole perspective of sometimes people make mistakes, and so there is human error. These days we are also realizing that sometimes technology makes mistakes, or machines make errors, so how much more the humans. So he brought that whole perspective into that, and he also wrote a special book he was an optician, about optics, right? And it was called the Book of Optics. And then next we want to talk about the Renaissance in Europe, and we want to introduce a gentleman who was called Roger Bacon. Roger Bacon is known for beginning to flesh out details about the scientific method the way we know it now. So he began to say things like, if you observe this and then you conduct an experiment on this, you will be able to make a conclusion based on what you've observed and the experiment that you did to prove or disprove something. And he also had a magnifying glass, so he was able to be a little bit more accurate than some of the other people. And I like to tell a funny story. I'll tell you about it later when we're learning about the cell. But remember, these people didn't even know cells existed. So when the first people were observing little animalcules walking under the microscope, and then the other people would be like, yeah, right, you saw little animals walking in the water. But now we know it was true. They really did. So with the scientific method, we are seeing that as they're developing their technology, as they're coming up with these new things, there's a lot of challenges because you don't know what you're doing and everybody else is like, well, which is a lot like what we're going through with Corona right now, right? Another European guy that we find is René Descartes, who was actually French. And René was a philosopher, he was a mathematician, and he was also a scientist. Like we said, a lot of people in that time were very diverse in terms of their skill set, right? And so René was like, I am never going to accept anything. Actually, what did he say? I am never going to accept anything for which I do not clearly know to be such. So he was going to avoid making conclusions if he could not prove to himself that this actually works. And he is credited with bringing deductive reasoning. You start with a principle, you deduce how it is applied, you reason on that particular situation, and maybe you can even experiment about it. And there's a couple of other people also that are worth mentioning in that time period, we're about now in the 15th century. And these are people like Galileo, who even went under house arrest. But one of the things that Galileo did or contributed was telling us, you can measure like this, or you can measure like this, or you can measure like this, and everybody was measuring differently. So to come up with a standardized measure, so that if you measure in one place, if you measure in Italy, then the people in France will know what you're doing, the people in England will know what you're doing. So he's credited with helping us to standardize these measurements. And he was, of course, an astronomer, a physicist, an engineer, a philosopher, a mathematician. So he was a lot of good things, and he contributed that way. The other person that we're interested in is Isaac Newton. I'm sure you remember about Isaac Newton and the apple on his head. So there's Isaac Newton and the laws of motion, Newton's laws of motion. But he is also, as regards the scientific method, he's credited with saying that if you come from a principle and come to a conclusion, or if you come from parts and then grow them back to get the whole, whether you're coming from the whole to the parts or from the parts to the whole, you need both of them in different fields to make good conclusions when you're talking about science. And he's credited with doing that. Obviously, there's many other people that continue to contribute to this method that we haven't talked about. There was Louis Pasteur and the pasteurization and the germ theory and all that. So there's many other scientists that in finding out whatever field science they were working with, they contributed to the field of science. And we've just mentioned like a few. There is many more, and we haven't even talked in detail about what they did, but we just wanted to show that progressively over time they came up with different ideas, and then they came up with the scientific method that we know for making an observation, hypothesis, prediction, experimentation, data collection, conclusions, and repeating and realizing that this is integrated. So once that, like by the time beginning of the late 18th, early 19th century, this was established as this is how we do science, and everybody accepted that. But in more recent times, like in the early 1900s, some other people began to come up that began to question things. And Karl Popper was one of them. He was an Austrian philosopher, and he came up with the suggestions like, why are you saying that this is the absolute truth? There is no absolute truth. Because if you could test it, maybe you need to find a way to test it, and then you will be able to know. And that's when we talked about falsifiable, which in science doesn't mean that it's not true, but it means that you're able to test it further. Do you have a falsifiable hypothesis? So sometimes as close as you can get, to to something acceptable in science is more like a theory, because as Karl Popper was saying, there is absolutely no way you'll say that I will absolutely not ever be able to test this further. This is forever the truth, and so as close as we can get to saying this is a truth, which is like a fact in science, is when we call it a scientific theory, not an idea. And then the other guy was Thomas Kuhn, and he was actually an American, and he died maybe, no, not your lifetime, but 1996, that's when he died. But he was an American. He was a physicist, he was a historian, he was a philosopher as well, a science philosopher, and he was reasoning, looking at how trends happen over time, that in science you have paradigm shifts, where this is what people believe for a time, and then some people dissent based on some evidence, and then people move to that, and then after some time again people dissent and move to that. And we've actually seen it when we've been talking about masks, and it didn't even take 100 years. Back at the beginning of the semester, of the spring semester, it was like, nobody needs a mask, we don't need masks, we can do without masks, and everybody was like, only the medics need masks, so the masks are not to help us. And then more research was done and people talked about it, and now the popular public opinion is that masks are helpful, masks help you. And so what he was talking about, there being paradigm shifts that shift, and people have faith in this until there is more evidence that leads to a shift into believing something. So he was like, these absolute science things that we think or hold true to are for a time, and if we get more evidence, there is a paradigm shift to something else. And the final person who I find very interesting was actually Paul Feyerabend, and he was an Austrian originally. He was a professor at the University of California, Berkeley, is that how you say it, Berkeley? And he is credited with questioning. Karl Popper began to question, but Feyerabend also questions the scientific method as we know it. And he said, why does it have to be a monopoly? Why does the scientific method have to be a monopoly? Because it's restricted to just to the natural sciences. But in other places, we need different ways to be able to test things and investigate them. And sometimes you might not be able to observe everything, even though it's true. And he wrote a book that was like against method and science in a free society, and was like, that is a way of like colonizing people almost, if you don't allow them to be able to think freely. So that's another interesting part. So this little portion was just to give you an idea that the scientific method, getting to where it is, has been a journey. And even now that we are where we are, there are people that are questioning, there are philosophers that are asking, is this really the way? And like before we thought it was stepwise, and now we are like, oh, maybe it's convoluted, it's not stepwise. And you might start here with a hypothesis and then go back and make observations, and you could go around in different ways. And so thanks for your attention, and have a great day.